Brendan, do you have a question, or do I need to repeat an answer? Okay, excellent. So we'll do it next, okay? So let's take a look at 28. Is there anybody that needs me to repeat an answer? I forgot to say that part. I didn't check yours in. Okay, let's take a look at 28. Right now for myself to make sure I got it. Okay. Same thing with Addie. You both showed me your chapter reviews, so I'm just going to make sure that they're in there. Thank you, Mom. Okay. All right, so page 133, you said 28? Yes? 28? Awesome. Okay. So 28 told us that we did one of these in class that you could have used as your guide. So we did do one of these in class. They told us that it says find the perimeter of the square. So we have a square. We want to find perimeter. All right, well, we know that both sides are equal to each other. So the other side is 36 minus 5x. So we know it's a square. We can't find the perimeter until we know what x is. All right, so the first thing we need to do is we need to find x first. Well, I know that it's a square, so these two are equal to each other. So 4x is equal to 36 minus 5x. All right. I'm going to do adding the opposite right now. So now I'm going to start solving this. All right. So this is 36 plus a negative 5x. I'm going to add 5x to both sides. Don't forget to keep the x with it. The negative 5x and the positive 5x go away. So I end up with 9x is equal to 36. I'm going to divide both sides by 9. X equals 4. All right, so I found what x equals, but that's not what they were asking for. They were asking for the perimeter. All right, so if I go back up into here, let's figure out what one of my sides is. Well, one of my sides is 4 times x. So this is 4 times 4, which is 16. So that's one of my sides. So my perimeter of a square is 4 times one of my side lengths. I'm just going to make it L. So we end up with 4 times 16, which is a perimeter of 64 units squared. So please make sure that you answer their question. Many of you found x, but then you never went back to check to see what the perimeter was. Ada. Oh, no, perimeter. Thank you, not area. Thank you for checking that. It's just units. I saw the multiplication. I was thinking squared. Who asked me for that? Are you cool with that? Awesome. Brendan, what can I do? All right, let's take a look at 34. All right, so 34. These are types that I would give you guys. Our problems 34 through 37, these are ones you're going to see on a homework quiz as an advanced group. All right, so 34 said I have 3x minus 7 is equal to 8 plus 6 times the quantity of x plus 2. You guys, you have to follow order of operations. How many of you guys added 8 and 6 first? How many of you guys added 8 and 6 first? There's more than one of you. All right, there's more. All right, you have to follow order of operations. So what should I be doing first here? Brendan? Excellent. You have to do that distributive property first. So on my left side, I have 3x. I'm going to do plus a negative 7, just because I like to do adding everything, is equal to 8 plus 6 times x plus 6 times 2. By the way, I want to see that. All right, So I have 3x plus negative 7 is equal to 8 plus 6x plus 12. Now what do I expect you to do? Cameron? Talk louder. Excellent. That's exactly right. We're going to use the commutative property to move the 8 and the 12 next to each other so I can add them. That is a requirement of mine. So I end up with 3x plus negative 7 is equal to 20 plus 6x. So now that I have both sides simplified as far as I can go, now what? Colin, what should I do?
You add negative 6x to both variable terms.
Excellent. And again, you could have added 3x to both sides. You could have added 7 to both sides. You could have added negative 20 to both sides. So there's 4 different ways you could have started this. All right, so Colin, I'm left with negative 3x plus negative 7 equals 20. Now what would you like me to do?
Would add 7 to both sides.
Excellent. So I get negative 3x is equal to 27. And now what?
You would divide negative 3 and 27, which would give you x would be equal to negative 9.
Excellent. Nice job. And again, if you didn't start adding negative 6 to both sides, you could have added negative 3x to both sides. You know, there's 4 different ways you could have started that and still get the same answer. All right, what else? Alex? Say that one more time.
35.
Thank you. That fan on the vent is really loud, and I'm having a hard time hearing you guys, so thank you. So 35. So 35 said I have 13y plus 19 is equal to 6 times the quantity of 9 plus y, and then plus 14. So somebody tell me, what does order of operations tell me I have to do first? Ada? Okay. Excellent. All right, so I'm going to do that distributive property first. So I have 13y plus 19 is equal to 54 plus 6y plus 14. Ada, now what? Yep. Excellent. So that's going to be 868. All right, now what, sweetie? What would you like to do? So I get 7y plus 19 is equal to 68. Now what? All right, so I get 7y is equal to 949. Awesome. Excellent, nice job. Alex, does that help you?
Yes.
Colin, sit up, please. Sit up, please. Danny, all the way up. What else can I do for you guys? Colin?
24.
24. Okay, 24 says 3 less than 11 times a number is equal to 9 plus 5 times the number. All right, so that's our given. So I have 3 less than 11 times a number is equal to 9 plus 5 times the number. Okay, so let's take this apart. Here's the first part of the equal sign, here's the second half of the equal sign. All right, so when I take a look at this, it's the less than part that throws a lot of people off. If I have an amount less than another amount, this means I'm going to be subtracting 3 from whatever comes after it. That's what that means. So this first part means I have to take 11 times a number. I'm just going to write n for the number. And then I have to subtract 3 off of it. So this first part is 11 times n minus 3 equals, well, you're adding 9 to something. And I'm going to add 9 to 5 times that same number. So are you cool with that? All right, so now I'm going to finish solving this because I think they told us to solve it. So I'm going to add a negative 5n to both sides. And I get 6n plus negative 3 is equal to 9. God bless you. I'm going to add 3 to each side. I get 6n equals 12, and then when I finish, I get n equals 2. I think that 3 less than 11 times a number is usually what throws people, because they think, oh, I have to do negative 3 minus 11n, and that's not true. When you have that less than, that goes at the end. All right, what else can I do for you guys? AJ? 18? Sure. So 18 said I have 14a minus 93 is equal to 49 minus 57a. Is this the one you're talking about? Okay. I'm going to do adding the opposite right away. What did you start adding? Excellent. All right, well, my 14a's cancel out, so I have a negative 93 is equal to 49 plus. Well, I'm adding 2 numbers with the same sign, so I'm just going to add these. 7 plus 4 is 11. Carry the 1. That's 6, 7. That's going to be a negative 71, I think, if I did that right. All right, and now I'm just going to add a negative 49 to each side. All right, the important thing here is watching those signs. It's really easy to lose the negative signs. Colin, sit up, please. It's really easy to lose those negative signs, so don't lose them. I'm adding 2 numbers with the same sign, so I'm just going to add them. 9 plus 3 is 12. Carry the 1. That's going to give me a 14, and it's negative, is equal to a negative 71a. All right, so now I'm going to divide each side by negative 71, and I get a is equal to 2. Are you cool? Did you find your mistake? So you got 17? I don't know how you did that either. You did some sort of subtraction, I just don't think you were paying attention. All right, put this away, get your notes out. All right, so today is the 28th. We are still doing Chapter 3, Section 3. So 3.3 continued. So this is solving equations with variables on both sides. We're going to focus today on story problems, but then we're also going to look at different options of solutions. And Valentina, this is going to go back to your question of what does all numbers mean. All right, so we're going to get to that right now. Okay, so let's talk about story problems. When we have story problems that would be in this situation, where we have variables on both sides, what you want to look for, you are comparing 2 different situations with similar information. that's kind of what we're looking for. You're going to probably have 2 rates, 1 for each situation. All right, so when you read story problems, you're like, okay, what is it that I'm talking about? Like, what is this? What kind of problem am I looking at? All right, so let me show you exactly what it is I'm talking about. Okay, let me show you this example that I want us to do. Okay. So let me read through this with you. It says, the Spanish Club, just read it with me. The Spanish Club is arranging a trip to the Mexican restaurant in a nearby city. Those who go must share the $60 cost of using the school bus. The restaurant's buffet is $5 per person. How many students must sign up for this trip in order to limit the cost to $10 per student? All right, so let's kind of write down, first of all, write all that down. And let's figure out how we're going to solve this. And this is when your game plans are critical. Okay. So this is what I have written down. We're going to a restaurant. All right. The cost of going to the restaurant is going to be $60 for the bus, and then $5 per person at the restaurant. All right. We want this cost to be $10 per person. All right, so what we want is, we want our goal cost to equal our actual cost. Can you guys see that? How many of you guys can see that that's what we have? All right, this $10 a person, this is our goal. The $60 for the bus and $5 per person, this is really our actual cost. We want to know for how many students are these two going to be exactly the same thing. All right, I've given you a general game plan to get you started off. I want you writing a specific game plan for this, and I want you to solve it. Don't lean in this chair. So I've given you a general game plan for this. I want you to write this as a specific game plan and then solve it. Go ahead. All right, talk to someone sitting by you. See if you guys have the right game plan. Help each other out. All right, if you notice, there are two rates. One goes with each situation. One goes with the goal, one goes with the actual cost. All right, let's talk about this. How do I figure out my goal cost? How do I figure out my goal cost? Matthew? Excellent. My cost per student times my number of students equals. How about my actual costs? How am I going to figure that out? Cullen? I mean, what am I paying for?
The cost per bus, cost of a bus,
So this is the cost of my bus plus
cost per person, for a buffet, times the number of people.
excellent. So cost per student times my number of students. Excellent. Well, I don't know my number of students, so there are my X's. Questions on this game plan? All right, so the number of the cost per student times my number of students for my goal is 10x. The bus is $60, and the buffet itself is 5 times x. All right, I'm just going to go ahead and solve this. So I get 5x is equal to 60. So how many students can go? Sophia? Yep, 12 students. Yes?
Where did you get the cost? Oh, not the cost here.
That's the cost for the buffet.
Yeah.
Yep, that's where the 5 comes from. So the actual costs are $5 per person for the buffet, and then $60 for the bus. Does that make sense? Okay. All right, let's talk about the possible solutions. So when we talk about solutions to equations, there is more than one possibility. So solutions to equations. There's actually 3 possibilities. We've only been dealing with one. Here, one of them is called one solution, and that's what we've been doing. This is when we have x is equal to 12 students. What this means is there is only one possible value for the variable, for the solution. And that's what we've been doing so far, is one solution. All right, but there are 2 other possibilities. One of them is called no solution. What that means is there is no value for the variable that makes the equation true. All right, so I want you guys to solve this problem. 5 times a quantity of x plus 1 is equal to 10x. All of you solve that and see what you come up with. So no solution means there is no value for the variable that makes the equation true. So solve this equation. How many of you got to 10x plus 5 equals 10x? All right. How many of you guys subtracted 10x from both sides? All right, or added a negative 10x? What did you find happened? What did you find happened? Sophia?
That when you added a negative 10x plus 5,
Well, there is something on the right side. So when you're over here, what is 10x plus a negative 10x? When we do that, like, why are we left with only 5? What is 10x plus a negative 10x? Amanda? 0. So isn't this on the left side actually 0 plus 5? How many of you guys would agree with that? Okay. Well, on the other side, what's 10x plus a negative 10x? Brendan? 0. So while there's nothing there, there is something there. It's a 0. So what we have is 5 equals 0. Well, does 5 equal 0? No, this is not true. So this is a no solution. So when we have a no solution, all right, our variable term cancels out. So our variable terms cancel out. And the right side does not equal the left. That's what we would find in a no solution. Kind of funky looking, isn't it? All right, I want you guys to do one more for me. This is a different one. Who needs to see what's up there? Hurry up, come on. What? I can't hear you. All right, well, you'll have to fill it in. You can come see me in my notes and fill it in. Okay, let's do one more. All right, so I want you to give you guys some space. This is going to be our third possibility. Give yourself some space there to fill in some notes, but I want you guys to solve this. 6x plus 2 is equal to 2 times a quantity of 3x plus 1. Solve that. Give yourself a bunch of space to make an explanation up here, but solve this equation. And I'm going to tell you what this one is called. So all of you solve this. How many of you guys got to 6x plus 2 equals 6x plus 2? All right, I'm going to go ahead and add a negative 6x to both sides. What happens to my 6x's? Alex? They become zeros. These two cancel each other out. So Alex, what am I left with? Excellent. So I have 2 equals 2. Is that true? Yeah, this is true. 2 does equal 2. This is what they call all real numbers. Another way that might be said is identity or infinite solutions. Different books say different things. Those all mean the same thing. So let's go back up and kind of define this in what all real numbers actually means. So if I go back up here, all real numbers is a possible solution. I'm going to put in there identity. My red book says identity, and my green book for advanced, or my regular says infinite solutions for 8th grade. Those all mean the same thing. So what that means is every value is a possible solution for the equation. All numbers make the equation true. So all numbers make the equation true. And if you notice, our variable terms cancel out as well. That's also something to notice about infinite solutions or all real numbers. All right, is that our variable terms cancel out. guys cool? All right, that's what it says at the top. Questions on this? So tonight you're doing story problems, you're going to be solving more equations. All right, so when you get to ones where you might have the variable term completely goes away, first of all, check to make sure you did your math right, because they won't always go away. But if you have done your math right now, you know what it actually means. You guys cool? Okay, you guys can go. Odds, go ahead.